Democritus lived from 460 BC to 370 BC. He studied natural philosophy and also enjoyed studying geometry as well. He wasn't the one who originally came up with the atomic theory. His mentor, Leucippus, actually did. The atomic theory stated that the universe is composed of two elements, the atoms and the void in which they exist and move. From this idea, Democritus came up with a hypothesis in 465 BC. This hypothesis, or atomic theory, stated that all matter consists of invisible particles called atoms. Atoms are indestructible, they are solid but invisible, are homogeneous, and atoms differ in size, shape, mass, position, and arrangement. John Dalton came up with his atomic theory in the early 1800s. In the 1780s, Lavoisier made careful quantitative measurements that allowed the compositions of compounds to be determined with accuracy. By 1799, Proust was able to establish the law of constant composition, and in 1803, Dalton noted that oxygen and carbon combine to make two compounds. This idea led him to propose the law of simple multiple proportions, and in order to explain how and why elements would combine with one another in fixed ratios and sometimes also in multiples of those ratios, Dalton formulated his atomic theory. Dalton's atomic theory stated that all matter is made of atoms, and atoms are invisible and indestructible. Also, that all atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms, and a chemical reaction is a rearrangement of atoms. Joseph John Thomson lived from 1856 to 1940. In 1897, he discovered the electron while doing a series of experiments designed to study the nature of electric discharge in a high vacuum cathode ray tube. This was being investigated by numerous scientists at the time. From his discovery, Thomson said that in his atomic theory that an atom consists of a sphere of positive charge with negatively charged electron embedded in it, and the positive and the negative charges in an atom are equal in magnitude, due to which an atom is electrically neutral. It has no overall negative or positive charge. Thomson's atomic theory model was nicknamed plum pudding. Thomson saw it as being similar because the negatively charged electrons were embedded in the positively charged sphere. Rutherford lived from 1871 to 1973. In 1903, he was able to deflect alpha rays with both electric and magnetic fields. Two of his students, Geiger and Marsden, conducted the classic foil alpha particle scattering experiment in 1906. This showed large deflections for a small fraction of incident particles. Rutherford suggested that hydrogen must have obtained the simplest possible rays. He also suggested that these must be the fundamental positively charged particles, which he called the proton, in 1914. He passed alpha particles through a gas of nitrogen and occasionally observed scintillation of hydrogen impacting on his screen in 1917, and he concluded that the alpha particles were knocking protons out of the nitrogen atoms. And this meant that he had made the first observation of nuclear reactions. Bohr proposed a shell model of the atom to explain how electrons can have stable orbits around the nucleus in 1913. He wanted to fix Rutherford's model because it was unstable. The reason why it was unstable is because any charged particle moving on a curved path emits electromagnetic radiation. If Rutherford's model was correct. The electrons would lose energy and spiral into the nucleus. In order to fix this problem, he made Rutherford's model change by requiring that electrons move in orbits of fixed size and energy. Erwin Schrödinger lived from 1887 to 1961. Bohr's model was where Schrödinger got his idea for the electron cloud model. Schrödinger's model depicted a floating motion of the electrons rather than them having a set path of travel. He said that the electrons stuck in their orbits would set up standing waves, so Bohr's model would not work. He said that you could describe only the probability of where an electron could be. It was not definite. And the distributions of these probabilities formed areas of space about the nucleus that were called orbitals. An orbital is a wave function describing the state of a single electron in an atom.